Hi all, today's topic is Geiger-Muller Counter. Geiger-Muller Counter, which is also known as GM counter, they are the oldest type of gas-filled detector used for detecting and measuring ionizing radiation. This counter invented by Geiger and Muller in 1928. This can be used to detect nuclear radiations such as alpha particles, beta particles and gamma rays. Here we can see the picture of GM counter. Now let us understand what is the working principle behind this counter. The GM counter works on the principle of ionization of medium by charged particles and it is based on gas multiplication. Now we will move to its construction. Here we can see a schematic diagram of GM counter. It consists of what are they? A metal tube which is also known as GM tube, which is nothing but a hollow cylinder. So this metallic cylinder hollow from inside and contains gaseous mixture of 90% argon and 10% ethyl alcohol vapor. Now the metallic cylinder is connected to the negative terminal of the very high tension battery. So this metallic cylinder acts as a cathode. And here we can see through the center of cylinder we have a metallic electrode which is made up of tungsten, that is basically connected to a load resistance say R, and which is again connected to the positive terminal of the same power supply. So this electrode acts as a anode, and here at one end of the tube a thin window of mica is arranged to allow the entry of radiation into the tube. A DC potential of about 1200 volt is applied between the cathode and anode, and here the across the load resistance electronic setup is present which is capable of measuring current pulse and also detect the radiations which are present in the tube. This is the construction of GM counter. Now let us understand how the counter works. When a charged particle enters the GM counter, it collides with the argon atom to cause primary ionization and thereby produce electron positive argon ion pair. Let us briefly see what is the process of ionization. We know that whenever a energetic charged particle having high kinetic energy collides with another atom, then it knocks off or takes out electron from that atom. So what we get? We get electron, and since the electron is coming out of that atom, we get positive ion. This simple process is called ionization. So here in primary ionization we get electron and positive ion of argon. This electron will be accelerated towards the anode and the positive charged ions are accelerated towards the metal tube. But on the way to the anode, this electron will collide with the other argon atom and produce more electron positive ion pair. This is secondary ionization. This process is called avalanche or Townsend avalanche. So what is an avalanche? Avalanche is a process in which number of free electrons ionizing the atoms by collision thereby forms new electrons. The basic condition for Geiger discharge is Townsend avalanche created by single origin electron can itself trigger a second avalanche at different position in a tube. In this way, a large number of electrons accumulated around the anode. This flood of electrons, or we can say avalanche, around the anode due to secondary ionization is called amplification in GM counter. We know whenever electrons move or they are displaced from one place to other in a circuit, then what will happen? It will produce current. So here the movement of electron produce a current which will flow through the resistance to produce a voltage pulse. Now this voltage is amplified and the amplified pulse is then given to the counter, which will then record the count. Thus the GM counter not only detects the incoming charged particle but also counts the number of charged particles. So this is the working of GM counter. Now let us see the GM counter characteristics. Here the figure shows GM counter characteristics. It is nothing but a plot of number of particles counted per unit time for the y-axis and the applied voltage on the x-axis. Now in this particular figure we can see up to 1000 volt there is no count. Why there is no count? Because there is no ionization up to 1000 volt. There is no discharge and hence the count record is 0. So the minimum voltage at which counting is recorded is called threshold voltage, or it is known as starting voltage. It is denoted by Vt. So the minimum voltage at which counting is recorded is called threshold voltage. Here the threshold voltage is 1000 volt. What is mean? Which means unless the GM counter getting an input voltage of 1000 volt, it will not record any count. It will not display any count. Now when the voltage is further increasing from 1000 volt to 1200 volt, what will happen? The number of counts increases linearly with applied voltage. This particular portion of the graph where the count is directly proportional to the applied voltage, that is a linear relationship. It is called a proportional region. Here above 1200 volt to 1500 volt, the count rate shows linear variation. It is almost constant. This particular region where the count rate in a GM counter is nearly constant, it is called plateau region, or it is known as Geiger region, or it is known as operating region. Then the GM counter will operate in this particular region. This plateau region, the GM counter will operate. Now if we increase the voltage further above 1500 volt, a continuous discharge will take place. Counter rate increases rapidly due to discharge of argon gas, which is undesirable. So voltage at which continuous discharge take place is called breakdown voltage. Here the breakdown voltage is at 1500 volt. In this continuous discharge region, the GM counter rate of counting, it goes on increasing and there is a possibility that counter will burn out. So whenever we are operating the GM counter, the first precaution that is taken is that the voltage applied never exceeds the breakdown voltage of GM counter. So here we have seen three type of region: proportional region, plateau region and continuous discharge region. This is the characteristic of GM counter. Now there are particular parameters for GM counter. First one is dead time, denoted by TD. What is dead time? Dead time is the time interval for which the GM counter stops counting and becomes inoperative, is called dead time. Why does a GM counter have a dead time? We have seen when a charged particle enters in a tube, it will collide with argon atom, thereby produce ionization, which result electron and positive ion. Then this electron are accelerate towards the positive anode. The positive ions are move slowly since they are bulky. So after some time, a large number of positive ions get collected in the region around the anode. So what happens? Due to the accumulation of positive ion around the anode, when further electron positive ion pair is produced, that electron begin to travel towards the anode. That electron will travel towards the anode, but on the way towards anode, this electron may be absorbed by the positive ions. So the electrons are now not able to reach the anode. It gets absorbed by the positive ions. Since electron cannot reach into the anode, there is no current. Then voltage pulse may not produced in the display, and this display there is no counting. So for a short duration, GM counter has stopped counting and it has become inoperative, or we can say it is in non-operating state. So that the particular time for which GM counter has become inoperative, it has stopped counting. It is called dead time. Okay. After some time, the counter again meets its original state and it will produce a voltage pulse and it will again start counting. This time is called recovery time. The third parameter is response time. It is nothing but the sum of dead time and recovery time. Now, in GM counter, there is important concept called quenching. Why is quenching? What's necessary of quenching? When an energetic particles enters in a Geiger tube, produce electron positive ion pair by process of ionization that we have already seen. The electron is quickly accelerated towards the anode while the positive ion moves slowly as it is heavy or bulky, so they collect around the anode to form a positive ion sheath. If the positive ion remains around the anode for a period more than dead time, then the working of GM counter is affected. So because the electrons moving towards the anode may combine with positive ions around the anode, this produces a photons. So the combination of electron and positive ions produces photons. This emitted photon may collide with the argon atom and knocks out an electron from it. Also, the emitted photon may be incident on the walls of Geiger tube and may knocks out electron to produce photoelectron. We are familiarized with the photoelectric effect. What is photoelectric effect? Which is the emission of electron from the surface of metal when light energy is incident on it. Okay, so in this particular case, the photons are incident on the metallic wall surface and it knocks out electron. So these electrons are nothing but photoelectron. So what we get? After some time, a large number of photoelectrons are produced due to secondary ionization, avalanche effect caused due to photons. Okay, but here we can see now the counter is in a confusion state and produces two voltage pulses. One pulse is due to the secondary ionization avalanche effect caused due to photons, and another pulse is due to secondary ionization effect caused due to incoming particle. This is undesirable for the working of GM counter. Why it is undesirable? Because the particle which is entering produce one pulse due to secondary ionization. At the same time, secondary ionization avalanche effect due to photons, they also produce another pulse, which is a false pulse, not related to the incoming particle. Hence, for the proper working, the secondary ionization avalanche effect caused due to photons must be suppressed. Then only we get correct pulse. And the process of suppression of secondary ionization avalanche effect caused due to photon is called quenching. Okay, so the quenching can be done in two ways. One is external quenching and second one is self quenching. What is external quenching? In external quenching, the electronic circuits are connected externally to the counter to suppress the unwanted voltage pulse, which is produced due to the photoelectron emitted by the photon. And the second method of achieving quenching is self-quenching, or it is also known as internal quenching. In this method, 10% ethyl alcohol is added to the GM counter. The alcoholic molecules are heavy or bulky in nature, that we already know. They are organic molecule. Okay, then whenever a photon falls on this organic molecule, they will easily absorb the photon without breaking themselves. So in this particular case, the photons which are produced, they are absorbed by the organic ethyl alcohol molecules. This is the reason why GM counter consists of 90% argon gas and 10% ethyl alcohol, maybe in a gaseous forms. So these are the two ways of quenching. Then now we will understand what is the difference between GM counter and proportional counter. In GM counter, the pulse produced independent of the number of initial ion pairs formed by the impinging radiation. Whereas in the case of proportional counter, the pulse is proportional to the primary ions produced. That is the major difference between the proportional counter and GM counter. Now we will move to counting efficiency. The efficiency of detection of alpha and beta particles is determined by the probability that these particles penetrate through the window of GM counter to reach the active volume. So here the GM counter with the window of thickness of as small as few milligrams per centimeter square are employed for alpha counting, while for beta counting, thicker window counters can be used. For low energy gamma rays and X-rays, thin window counters filled with high gases such as krypton and xenon to a high pressure are employed to achieve good counting efficiency. And the efficiency of counting is the ratio of number of counts observed per unit time to the number of ionizing particles which passes through the counter during that time. Now, what is the advantage of GM counter? It is very sensitive even for production of single ion pair. Then the pulse height is independent of nature and the energy of incident particle. And the last one is the height of pulse is almost constant over a wide range of applied voltage. Now we will move to what are the disadvantages of the GM counter. First one is GM counter is not suitable for energy spectroscopy of the radiation, and they have low efficiency of counting gamma rays, and they cannot detect uncharged particles like neutrons, and this counter has limited life because of quenching gases. But this disadvantage can be eliminated by the use of halogens as quench gases. So this is all about the GM counters, its principle, working, construction, advantage and disadvantage. I hope all of us clear. Thank you.